Yeah. Do you mind if I record it?
No problem.
Okay.
I was gonna start my and no. I can write on it here. Yeah, and
Okay.
I think that will be sufficient for the time being.
Yeah.
If
Let me.
oh, sorry, no. Can you share your slides again so I have the white
Oh,
background? Oh, I can actually do otherwise I can do this.
I can share.
Yeah, it's just on because now I can actually see here. I can I need to, if you give me the slides that you had, that's better. There, perfect, because now I can write.
Yeah.
I that should be good. Okay, so the way we did it in class is that we talked essentially from a stochastic processes point of view, right? We didn't necessarily do a full-blown modeling and all this, and we used the random walk, right? So up or down with probability half. So in practice on the market, so if you do the CRR model, which is the Cox, Ross, and Rubinstein model, you may have heard about this in the derivatives class or something like this.
Yeah, I haven't taken those.
Okay.
CRR model, okay.
So if you look at this, the way you do it is you say, okay, my stock at the nth step, what is it going to be? It's going to be the stock at step n minus 1, right? Let me erase that. I'm not going to need it. And we're going to multiply it by an exponential. And this exponential is going to be, in general, we're going to put, if I did that, right, mu delta t, and delta t is the time between period n minus 1 and n, right?
Right.
So, you know, I can make my steps. And so if this is days, day number n and day number n plus 1, right? Delta t would be 1 over 252, or how many trading days you have in the year, right? So if I do just that, this is a standard growth model, right? That means your stock grows at rate mu, right?
Right.
So if you can think of mu as being R, right?
Mu is the what? I'm sorry.
Mu is a rate, right?
Yeah, the rate of growth.
It's the rate of growth. And if I stop here, this is just growing like this, right?
Yes.
Yeah. So what we do then to incorporate the random walk is that we do this. We say, okay, now I'm going to put plus or minus sigma square root delta t, right? And so now if it goes up, now we're going to do a model where it can go up or down at each step. If it goes up, it's going to be sigma square root delta t. If it goes down, it's going to be minus sigma root delta t. So what we're saying is that if it goes up, it's going to be mu delta t plus a little bit. And if it goes down, it's going to be mu delta t minus a little bit.
But isn't E always going to be positive?
Yes. It's a multiplication here, right?
Oh, okay.
So what happens is that if mu plus sigma is positive, let me assume delta t is 1 for simplicity. That means your exponential is positive and larger than 1, right? So then your stock grows. If mu minus sigma, on the other hand, is negative, then the exponential is still positive, but it's less than 1. So it goes down. But this is something like multiply by 1.05. This is like plus 5%, right?
I see.
And multiplying by 0.95, this is minus 5%, right?
Mm-hmm.
So that's why we use an exponential, because then positive values inside the exponential means up, negative values mean down. Okay. You want your exponential, because if the exponential could become negative, then you would get Sn is negative. So this is the stock price. It's not the random walk.
Right.
Okay.
Yeah.
So my stock price is going to be either up or down. And here, typically, we take probability 1/2, right? Now, why did we do that? We did the probability 1/2 for mathematical reasons, right? Because we wanted it to be easy. And it's easier to know the random walk and all that. Most of what is known mathematically applies when the probability is 1/2. But in reality, that doesn't mean that your stock remains flat because we use this mu, right? So what we have is, okay, you start from here and growth mu would be here, right? So let's say you have S0 and that's S0 e to the mu t,
Right.
And what we're going to say is, okay, maybe up is here, right? It's a little bit more than mu t, and down is somewhere below mu t, right?
Yeah.
So they have probability 1/2, but they don't have to be symmetric, right? Because mu is not 0. So if you look at the average of the green and the red, maybe on average it's this. And your stock on average goes up or it goes down.
And because you're talking about the probability is 1/2, and I'm thinking, is there a way we can manipulate the probability just because we know like stuff like VIX and also the S&P 500 has a big, I wouldn't say implication. I would say it's a big factor of why people are selling or buying, just because if the whole market is down, you wouldn't be trying to buy individual stock that day.
Yes, so you would like to play with the probability, right?
Okay.
That's what you want, right? You would like your probability to not be 1/2 and essentially say, if P is less than 1/2, that means I'm going to be likely to go up, so I want to buy. And if P is bigger than 1/2, I'm going to be likely to go maybe the other way around. But
yeah, the other way around.
Yeah, yes, sorry. But yes, like if your probability to go up is high, you want to buy, right? So this is where I'm going with this, is that this is the math model that I'm introducing in the spring semester right now. We are looking at this. And so what you have is essentially this. Let me redo this picture maybe in a more simple way. So you start from some value today, like here. And I'm going to say, okay, they have my mu and sigma don't have to be symmetric, right? Mu plus sigma might be here, right? And mu minus sigma has to be there. Maybe it's, I don't know, only this, right?
Right.
So I'm forcing the probability 1/2, but I don't say that those have to be symmetric, right?
Right.
So I'm doing this, right? 1/2, 1/2, but it's not symmetric. So on average, my stock is going to do that. So on average, it goes up, but on average, it could go down, right? So this is the model as I would use it from a mathematical perspective. And that's, we like to enforce the 1/2, right?
Right.
And in reality, what happens is that here, I can write this like that, right? Let me finish my equations. Another way to rewrite this is like this. I put always plus, right? But now I'm going to put an xn here. And this xn is plus or minus 1 with probability 1/2, right?
Right.
That's the same as what I said, or we choose plus or minus, right, in the upper equation. I just coded that in a mathematical way. Now, if I do that, what I can do is I can iterate this equation, right? Because now Sn minus 1 is going to be Sn minus 2 times another exponential. So altogether, you're going to get that this is the initial value times an exponential, and it's going to be delta t times n. I'm going to put this mu delta t n times, right? And then here I'll have the sigma square root delta t, and I'll have the sum of the xn. Because I'm going to multiply every time, but it's inside an exponential, so my multiplication will become a sum, right?
I'm a little bit confused with where do we get the sigma in this?
So I'm doing, you see, here I found this, you're okay until here, right?
Yeah.
Yes. You're okay until here.
Mhm.
So now what I'm going to do is I said, oh, look, the stock at time n, it's the stock at time n minus 1 times this. But the stock, now I can use the same equation to write this one as stock n minus 2 times an exponential.
Oh,
Right?
I
The
see.
stock at time n minus 1, and then I can do sigma root delta t, but this time it's xn minus 1, right?
Oh, so we're not taking account of what happened today. Because we're doing the xn minus 1. So we basically
yes.
move the timeline more
so
like towards the
and
past.
each interval will have a plus or a minus 1, right?
Mhm.
And so now my stock at time n here, right? If I'm here at time n, I can express it from time n minus 1.
Right.
But now the stock at time n minus 1, I can write it from time n minus 2, but it's a different x. Right? There's an x here and there's an x here, but they're not the same.
I see.
Right? It's a different draw of the coin, right?
Yeah.
So altogether, when I do this all the way down to time 0, assuming time 0 is today, right? Then here you're getting that this is a sum from k equals 1 to n of xk. Because you go back all like this all the way to time 0.
Okay. And just going back to the mu, like you said about rate, I talked to Hua, and then we have an idea is maybe because we have 5 years, and that's roughly about 1,000 days. What if we can statistically basically give it a curve, a distribution, and we're gonna have, let's just say, 10% of the days are -5%, and 10% of the days is going to be plus 5%, 10%. And then in the middle, you're going to have a huge cluster of going to be a growth of 1.1% or 1.2%, and basically create like a curve. So how do we really pick a point of which rate do we want to represent how the stock is generally doing?
So you want to, what you want to say basically here, I use the same mu every day, right? What you want to do is say, oh, I'm going to have mu that's different every day, right? Okay. So I think that's a good point. What you can do is do that. You can say, okay, this is my stock today, and it could go up here, it could go down here, or it could kind of remain in the middle, and maybe there's more than one option in there, right?
Right.
And based on this, you want to basically create a distribution like this. So I'm kind of drawing an axis here, and for each value, you have a likelihood of being chosen, right? So this is maybe 10%, and this is 10%, and then the rest in the middle is more likely, right? That's kind of what you have in mind, right?
Yeah.
Am I summarizing that correctly?
Yes, 100%.
Yeah. So you could look at this, and now basically what you will have with your 1,000 days is a sample of that, right? So you could say, okay, now I'm going to try to build a distribution based on this.
Right.
Now it depends on how much you want to specify, right? You need to pick a model. So what I'm doing here, if you want, sorry, that's not what I meant to do. What I'm doing here, when I do this model with the mu and sigma, is I'm going to say, okay, what I'm going to do is I'm going to take my 5 years, calculate the average, and maybe that's my mu, right? And I'm going to assume that my distribution is normal, and the second parameter that I'm going to estimate is the variance sigma. And then I take a normal distribution for my returns of mean mu and variance sigma squared. Okay.
Okay.
This is the idea. And then you pick every day, you pick a return, right, with mean mu and variance sigma square. But maybe you don't want to do that, right? Maybe you would like something that's a little bit simpler and maybe not continuous, right? If you had discrete options, it might be better for your machine learning algorithm, right?
Yeah, that's what I'm thinking.
Yeah, it's fine. It's fine. So now what you need to do is basically specify a setting and then try to find those with the data you have, right? So you might say, okay, my model is going to be okay. I'm not going to take this continuous normal distribution. I'm going to say, okay, as you said, there's maybe +5, right? -5. Those are the extreme ones. And then maybe, I don't know, if you want only one value in the middle or if you want more, let me just put 1, right? I could have, okay, that's sort of the average day, and maybe the average day is, I don't know, +0.5, right? Let's say those are the 3 possibilities and there's nothing else, right?
Yeah.
Now what you need to do is look at your data and estimate those probabilities from the data, right? You need to find now a P1, a P2, and a P3, right?
Right.
That's what you need. And you said, oh, maybe we'll say it's 10%, but really it should change with your data, right?
Yeah.
Yeah, you should use your 5 years of data to try and find out what this is, right?
Okay. And then just because we don't want to run a simulation based on one stock and its previous performance, we also want to incorporate how the other stock is doing. And then I talked to Hua. He said we can basically combine all the distribution by using Copula. I don't know what that is. So
yeah, you mean Copula, right?
yes, yeah, that's what he told me.
It's like this.
Copula. Okay.
So I'm not an expert at this. So yes, it's a statistics tool. It's like a computational statistics tool, Copula, that you can put it as part of machine learning if you want, or data feeding or something like that. It's a tool of data science essentially.
Okay.
That allows you to incorporate correlations between different processes, right? Here, with what we said, with the P1, P2, P3, you could calculate your probabilities, but you're going to end up with a model that's based only on that one stock, right? You're going to take one asset, whichever, I don't know if you're using only stocks, but you take one asset and that's what you get, right? It's up, down, or middle. But you may want to indeed use that as sort of a general model. Now, if you remain discrete like this, it's not so bad, because you could do something like, okay, and that's not necessarily Copula. It's a different idea that I'm throwing out there. Is that when you look at your 2 red events or the orange events, you could say, first, I'm going to determine a probability like that for the market as a whole, right? Like, is the market in a strong day?
Right.
Or is the market in a bad day? And basically you're saying, well, if the market is a bad day for, general economic reasons, like, I don't know, maybe Russia invades Ukraine, okay, bad day for the market, right?
Yeah.
Then all the stocks are much more likely to go down.
Right.
Right. Maybe there's a couple stocks who are going to stay middle, because, I don't know, maybe one is a weapons manufacturer, and for them, Russia invading Ukraine is not so bad. They're going to sell weapons, right? I don't know. You can imagine things like that. So, maybe depending on what the market is, you have different distributions, right? So you could have a P1, P2, P3 for each of, and you make a little table, basically. And that's a way to control you could have like good days, right? Bad days and average days, right? With the same logic, kind of. and those probabilities are not the same, right? And you try to estimate that, and now that's kind of estimating 9 values, right? Instead of 3. So a copula is a way to kind of do that. You choose a distribution and you try to match your distribution based on those estimation of correlations and these kind of things. But honestly, I'm not an expert at how to do that. That would probably be a question for Professor Wu, who teaches stat computing and these kind of things.
Okay, yeah, I will see.
But yes, this is something that people do a lot in data science.
Okay,
My little
I'll
idea
try to
here,
explore that option.
yeah,
Yeah, and
my little idea here is to say, well, you know, maybe on a good day, this is now not 10%, maybe this is 50%, right? And this is 40, and this is only 10. And maybe my numbers are not good. But on a bad day, it's the opposite, right? And on an average day, maybe it's really just that, right? If you see what I mean.
yeah,
So, you know, and then you could create the same kind of tables with joint stocks, right? Instead of taking market versus a given stock, you could have, you know, Apple versus IBM. And if Apple goes up, then the probabilities of IBM are changing. And that's kind of what Copula would be doing. In this kind of context. You would try to link all of them together. So you would not really throw, oh, each stock will be chosen independently, and you don't assume that the whole market behaves independently. You would choose them jointly with each other, right?
Mhm.
So you would say, okay, maybe first we pick the market, then, you know, if I did it on the whole S&P 500, and maybe in your field that you chose, it's different. But if I did on the whole S&P 500, I would say, okay, maybe there's the general market, good, bad, or average. And then based on that, you can go to subsectors. Then you throw a probability for
Like sectors and industry,
yeah, exactly. Like energy versus manufacturer versus electronics versus services, you know, something like this. And then you go down to the stocks, right? That could be another way to approach this. I'm not completely familiar with Copula, so it's not something I can really teach you, to be honest.
okay, yeah, I think that was really helpful, and I think that's everything I wanted to ask.
Yeah, okay. So you know, the way I showed you is the normal distribution. That's basically what I would show and teach in class. Like for each stock, we're going to try to fit a normal distribution for the returns, right? And so some days will be extreme, some days will be, most days will be in the middle, right? And that's kind of what you want to do. Now, if you want to control your data and maybe feed that into a random forest or, you know, neural networks, sometimes it's easier maybe to have discrete data and think about estimating 3 probabilities and not just, you know, the whole thing. And of course, here I put 3, and you could put, you know, 5, 7, how many you want, right?
Or we can just make it like 1 decimals after like 1 decimal. So that we have intervals, but it's still also
yes. So you're thinking like 0.1 to 0.2, 0.2 to 0.3, 0.3
yeah,
to
0.3 to 0.4, and then
yes, one thing to be careful with this is the amount of data you have. So if you have 1,000, you have
so maybe not 0.1, because we
yes.
do have 30 stocks, 5 years, that's 150. And then times 200 trading days.
Well, no, you're doing it on the trading day. So 1,000 days times 30 stocks, you have about 30,000 data points.
Right. And then if I try to split up the distribution by, I think I should just make it 1%.
Maybe,
so,
or half, maybe a half is fine.
Just to see how our computer power is doing.
Yes. I think another thing you can do, and I don't know if, you know, but maybe the right thing to do is to do that, you start from 0 and you have maybe a point, you do 0.1 up to 0.5, right?
Mhm.
And then 0.5. So 0.5 and the next cut is at 1. I don't know if you see what I'm saying. What I'm trying to suggest is you should put near 0 smaller intervals and then you can make it bigger.
Oh, that's a good idea. So anything above
Because-
5%, anything between, I would say -2 to 2%, I make it 0.1. And then when it reaches 3%, I make it 0.5. And it reaches more than 5%, I make it 1.
Yeah.
Okay.
Another
that
thing you
sounds
can
actually
do,
pretty good.
if I can throw another machine learning thing in this, you can also look at all your data and you say, look, what I would like is I would like to work with maybe 20 intervals, right? I don't know, I'm making it up, but maybe 20 intervals, right? Or let's say 30 intervals, so I can make the calculations nice. If you want to split in 30 intervals, right? Because if I look 0.1 between -5 and 5, that would be 100 intervals.
Right.
If you go to plus or minus 5% in ranges of 0.1. So on average, you're going to have 100 data points, 30,000 data. You're going to have 300 data points by interval. That sounds amazing, right? 300 data points should be enough to estimate the probability. But the problem is that you're going to get in here data points. You're going to get maybe 10,000 data points in the 0 interval, right?
Yeah.
And not very many in the 5%, right? So it's not really going to be, I mean, you expect that because you want the probabilities to be different, but it's not necessarily going to be distributed very well. And it's going to be hard to decide which one is the right cutoff. Like here, if I tell you 0.1, 0.5, and so on, you're kind of making this decision at random, right? You're just putting it out and okay, whatever, that's what it is. You could run something like a k-means algorithm to try and group your intervals. You could try to have a machine learning algorithm choosing your intervals for you.
Yeah. I think we're gonna try to keep it simple. We have less than 2.5 months to complete this.
Yeah, I mean, a k-means algorithm to see, basically what you would do here is you would put your 30,000 data points and you say, okay, where should we cut them off to have a good distribution? Right, between, let's say, plus and minus 10%. Should I make the intervals 0.1, 0.2? And if you do a k-means, it's going to group together the ones that are the most likely to look together. And where this cuts off, it's going to show you, okay, here 0.1 would be good. And then when you get to 1%, 0.3 would be good, and these kind of things. And that's a thing that's going to take on 30,000 data points, one dimensional. It's a 15-minute thing. I mean, you have to learn how to use it. But
Right. I'll definitely explore that idea. So the k-mean and the Copula are both right now as an option.
I mean, Copula, I know it's a popular thing. It's not something that I do. So I'm less of an expert on this, and I don't want to teach you something wrong.
Oh, yeah, no problem. Understood. But thank you so much for your time.
All right. You're welcome.
Yep.
Let me know if you have more questions coming up. Let me know.
Sure, no problem. Yeah, thank you so much.
Okay. Have a good afternoon.
You too.